We have arrived at our campsite Friday night. We're at Geyser Pass in the LaSalle Mountain Range west of Moab, Utah. And we're in a nice forested area in the alpine coniferous forest. And the alpine coniferous forest in Utah, so we drove up through the pinyon juniper, through a mixed woodland area with Gambel's oak, and then into a transition into the subalpine coniferous forest. And we've made it all the way up into the alpine coniferous forest. We're probably at about 10,000 feet elevation. And here in the alpine coniferous forest, well, I should just say the alpine coniferous forest is marked by a fewer number of species of trees, but a more dense treed area. So there's more trees, but there's fewer species of trees. And I see maybe 3 species of trees and maybe only 2. The 2 that I see are this fir tree here, Abies spa. I'm not sure what species it is. It's either white fir or subalpine fir. This tree right here. And the other tree that I see is Engelmann spruce, Picea engelmanni. And I'll just walk over to a big healthy Engelmann spruce. That's this tree right here. Engelmann spruce. And Engelmann spruce are interesting in the modern story of the West, because they're one of the trees that is really getting hammered by climate change, because and partially by the Forest Service's policy over the last 100 years of fire suppression. They're really sensitive to these beetles that burrow into their bark and eat the soft cambium layer. Spruce beetles. There's a bunch of different trees in the family Pinaceae. The pines have different beetles that they're susceptible to, and there's a spruce beetle that is really hammering the Engelmann spruce across the West. And I mentioned fire suppression because the big problem with these spruce trees is they've gotten too dense on the landscape in many places, and that stresses the plant's ability to take up water because they're competing for it essentially. And the main defense mechanism that spruce trees have against these burrowing spruce beetles is they flood the holes with sap and try and drown the beetles in sticky sap. But when they're too dense on the landscape, they become water stressed, and the trees can't effectively combat the spruce beetles. And climate change also, of course, is exacerbating that, reducing the amount of water available to the trees, both because of increased temperatures and because generally snowpacks are going down across the West. So they're just getting hammered from a number of fronts, and the spruce beetle is kind of the thing that really does them in. And another problem is the spruce beetles communicate with pheromones. Once they find a nice tree, they burrow into it, start eating it, and then they release this pheromone that attracts a bunch of other beetles. And so when the trees are really dense in an area, it's just free reign for the beetles to come in and destroy the trees. So here's a spruce tree that has been ravaged by the spruce beetles probably within the last couple of years. And you can see all these holes in the side of the tree. That's where beetles have burrowed in, get under the bark, and just ravage the tree from the inside. Some of the questions around this process are, there's a lot of sort of climate change skeptics or just general deniers of reality, I guess. And they say, oh, well, spruce beetles have been around for millennia, and these trees have been around for millennia, and this is just part of the forest's natural process. You know, the spruce bees will kill trees, and this isn't anything new. And in the RED lab, the University of Utah's Geography Paleoecology lab, they've actually asked the question, you know, is this a novel phenomenon that's happening? Is the current spruce beetle outbreak, is this novel, or is there a historical precedent for this, or a prehistoric precedent? And one of the students in, one of the PhD students in the RED lab did his PhD dissertation work on the Wasatch Plateau of central Utah and collected some sediment cores from some high elevation lakes in the middle of spruce fir forests, and looked at the relative abundance of spruces and forests and fir trees over time to ask that question, you know, is this current outbreak novel, or is there a precedent for it in the paleoecological record? So what happens is, typically, or at least what we've observed in Utah and across the West so far, is that the spruce trees get whacked back, they all die off, and then immediately the fir trees come in and replace them all. And so the question is, can we see evidence of switching back and forth between spruce and fir in terms of the pollen in paleoecological records? So Jesse Morris looked at these sediment cores and looked at the relative abundance of spruce and fir over the last 10,000 years on the Wasatch Plateau. And while there is some evidence that they do vary over time, the spruce trees, you know, when they decline a little bit, the firs tend to increase. And he also found a lot of actual beetles in the cores. So the actual casings of the dead beetles during outbreaks can find their way into these lakes and get deposited in the sediments. And then he was able to see both beetles in his cores, as well as changing relative abundance of spruce and fir pollen in these cores. But while he did see the evidence that these trees have co-varied over the past, he did not find a precedent in his cores for the severity of the replacement that's happening right now. The spruce trees are really just dying in vast groves across the West. This area doesn't look too bad. There's a lot of healthy spruce trees in here, but some areas on the Wasatch Plateau have seen 100% mortality for thousands of acres of spruce trees. So what Jesse Morris was able to conclude die-off paleoenvironmental information was this really is an unprecedented die-off of this tree species. No precedent in the prehistoric record.